Hey, what's going on, everybody? Welcome to luxurious Rutgers University in the Department of Computer Science. I got some stuff to do tonight, so I'm shooting this video here in my office. And it should be a quick one. We're going over the first third of your Unit 3 slides. This is the first review video for Unit 3. And if you've already given it a gander, you see that it's broken down into 3 different sections. We're going to do a little bit with functions, a little bit with file I/O, and then a little bit with modularity and libraries. Okay, but the first thing we want to talk about is functions. So let's get right to it so I can get you out of Dodge, and this shouldn't be bad at all. What do I usually do? I'm starting from scratch. Let's create a simple list. Any old list will do. And let me show you that we've been using functions all along. Print sum my list. And if we save that, we get 24. As you can see, sum is what's called a built-in function. Python has a series of functions that are built in and sitting there waiting for you to use, and you have already been using them, because if you think about it, what is int when you do casting? What is type when you look at a variable type? These are all built-in functions, and I think I brought up, yes, remember, the Python standard documentation is your friend, and you can look up the built-in functions and see all of the different functions that are built in and waiting for you. As you can see, there's not a lot of them, but we're going to solve that problem, but we're going to wait until the third part of the Unit 3 slides for you to learn about other libraries that you can import and use all of those different functions, but that's for later. First, we want to look at functions and see what they are. So you can see there's str, there's the sum, I just used that, there's int, there's input, you've used that. Then the next part of the unit, you're going to use open. There's a lot of, don't you ever use a val. Don't you let me see you, don't you do it. So you've already used functions, and if you look back to the slides, functions really have 3 different parts. One is the name. It's pretty much just like a variable name. The other part is the arguments or the parameters. In this case, the list is the argument and the parameter, okay? And then a function will usually have a return value or something that it returns, the answer to what you want to do. And in this case, it's 24, okay? We don't set it to a variable. We just print it out. But in this case, it's 24. So the name would be sum, and the argument list would be just one argument, and it would be my list, argument, parameters. There's different names for what goes in those parentheses. It gets sent to the function in order to use it to do its work and then return a value, in this case the return value. So the sum of all these items would be 24. So with functions, you have a name, you have an argument list, and you have a return value, okay? But the key to functions, and let me put it up here, functions, as you know, this code will be put up on the web when we're done with it. So I will leave this there for grand finale purposes, of course. But we are going to set about creating our own function right now. And what I think I've done for the last 3 years is I create a quick function of my own called multi-me or multi-cube. It's called multi-cube. And multi-cube will take 2 integers, multiply them together, and then cube that number. Okay? So how do I write my own function? I start with the def keyword. You can see idle makes it orange. Def is short for definition. I'm going to define a function right now. And what am I going to do? I'm going to give it a name. I'm going to call it multicube. Okay? And I'm going to take 2 integers. For this case, I'm just going to call them A and B. I don't need that space, but I always do include the space. I guess not. Let me try that. Okay? Then, like setting up a new code block, I hit the colon, and I do that. And now I'm ready to craft my function, which is really easy. I believe it's only 2 lines. What I'm going to do is I'm going to create a variable called z, and I'm going to make it equal to a times b. So I've done the multiplication part. Now I'm going to use the return keyword, okay, and just return z cubed. All right? So now whatever numbers I give it, they'll be multiplied, and then that result will be cubed, and that will be returned. So if I want to use it, let's say print multicube, and I don't know what I usually use for an example. I will go 2 and 2. So 2 times 2 is 4. 4 cubed is 4 times 4 is 16 times 4 again which is what? 16? 64. So I should be getting 64 for an answer. Let's see if my rudimentary math skills still work. They do. 64. Okay? So you might be saying, hey, great, like I do in that example in the slides. Hey, great. What do I care? You know, you could do it in a function. Why didn't you just do it regular? Well, because now I don't have to rewrite all that code for another instance. I just have to change it there. Okay? And I could copy and I could paste to my heart's content. So I could do it for 2, 3. I can do it for 2, 4. I can do it for 2, 5. Save, run, boom. And now I'm doing it for all those results. As far as that process is concerned, I've codified it. I've created a function. And now I have it to do for whatever I want. For I in range. Start at 1. Go to 11. So we'll do the first 10. Print. Multi-cube 2, comma, I. Save. Unexpected. What am I doing wrong? Print for I in range. Print multi-cube. How about another print? Thank you very much, Ido, for correcting me. Boom. Put it in a loop. Use it in a loop. Okay? So that's the basics of a function. We took some code, we put it off to the side, and we codified it up here, and then we're going to use it just like we use sum, just like we use int, just like we use input. Instead of a built-in function, we created it ourselves. Okay? And then we can use it in a whole host of ways. But as you can see, as far as anatomy is concerned, I have a name, I have argument lists, and I have a return value. I return the cube of z, which is the product of a and b. Easy peasy lemon squeezy. We just had our little departmental coffee hour, so I have my little styrofoam cup with my coffee in it. I don't have my big boy, my Dunkin' Donuts. It's already done. All right, 2 things left to talk about when we talk about functions. I'm going to leave multi-cube there to read, but I'm going to Zotz this part out. What if I, let's print multi-cube 3, 3. And we print that out and we get 729. Great. What if I come underneath here and I say print z? What's going to happen? Z is up here defined in the function z equals a times b, return that. So multi-cube 3 of 3. When I make that function call, I come up to multi-cube. A is equal to 3, first argument in the list. B is equal to 3. Second argument in the list. So down here, z is assigned a times b. So last time I checked, 3 times 3 was 9. So z should equal 9. And then I return z cubed, which down here is 729. But I want z. So z should be 9, right? Pregnant pause. Right? Another pregnant pause. Ready? Doom, 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 doom. An error. Name error. Name z is not defined. What's going on here? What's going on here is that when you have things in a function, think of them as a little side program that runs in its own little special section of memory. Because you know why? That's what's going on. That's the actual truth of the matter. So that when you call multi-cube, there's a special memory section set up. And it has a variable a equal to 3, and it has a variable b equal to 3, and then it creates a z and makes it equal to 9, and then it cubes it, and then it returns it. But the minute it returns it, boop, that little area goes away. Okay? Think of your whole program as what we call global space. Okay? Everything can see everything else. But you've got to think of a function running off to the side as what's called local space. And this particular state of affairs is called scope or scoping. When you run a function, it has a different scope. It goes off to the side of the main program, it does its business and returns its value, and then it disappears. So as far as Python is concerned, z does not exist. Z existed in this context when this runs. If I want to see z, I can do print z here. I can do that all day long. That'll work, as I will show you. Now I'm printing out the 9 because I'm doing it up here in the midst of the function. So I'm doing it in that context. If I try to do it down here, That function has already run and is out of memory, and Python tells me to go pound salt because it doesn't know what Z is. It has no idea. You must remember that when you use variables inside a context in here, the same thing would happen to me if I tried to print A. Okay? There's no A out there. A is not defined. A is a variable that is used in the context of that function. I wouldn't lie to you. Same with B. Okay? It doesn't know what these things are. As a matter of fact, it knows no variable. The only real variable it knows is the pointer to the function. Okay? Because technically multicube is a variable that points towards that function code. Okay? But we're going to think of it as a function and not a variable because I'm not interested in confusing the hell out of you. But back in the old days, we would call that a handle. And that's technically just a variable, and it just points to a memory location, and that's where that function is. Okay? That's behind the scenes. You never mind the man behind the curtain. I am the great and mighty Oz. You don't have to worry about that nonsense. What you have to worry about is that when you name your functions, you have to use the same conventions as variables. Just avoid numbers, avoid double underscores because they have meaning in Python that we're going to talk about later. We call them dunders. We'll get to that later. But for right now, I just wanted to go into scoping a little bit and show you a little bit about scoping. All right. Now, one more thing we're going to take a look at before we get out of Dodge. I'm just going to run the function. Multicube 3, 3. What's going to happen? Nothing. Okay? Didn't give me an error. It ran. The problem is, what? Pregnant pause as you answer. The problem is that I didn't capture the value. If you remember the slides, multicube is what we call a fruitful function. It's returning something. So when it returns something, when I run it, I want to make sure I'm ready to capture that value. Now, when I'm using it in a print context, I just take that value and throw it to the screen. So I'm seeing it, but I'm not really saving it. We can do one of two things. If you want to see the value, you can always print it and do it that way. So now when we rerun, we get our 729. But the classic way that most people do things is they'll stick it in a variable. I'll call this MC for multicube. And we'll save that variable, and then when I want to print, I can print MC. And the reason people will do that is because now I can use MC for different things. If I want to add a couple of them later, or if I want to keep them in a list, or I want to do something like that. So I'll capture the result of multicube using a variable, and then I'll print the variable. As you can see, the result is the same. But I always, use variables. Because like I always said, in this day and age, we're lousy with memory. Memory is not an issue with us. So go ahead and create the variable and use the variable. All right? Now, technically, and I don't know why I'm doing this because I don't have time to do all the 100 different videos. The other night I shot your video on the rainfall problem, so I'll get that to you. I might even give it to you tonight. I don't want to overload you, but I'm going to give you this tonight. It's Tuesday, the 10th, and I may just give you the rainfall tonight too. But then I also have to do the second review video and the third review video. But then I also want to do a video for your quiz. Maybe I do that super late tonight at like midnight. I don't know. I shouldn't be wasting your time with all my stupid planning. But I've got like potentially 4 more videos to get you for this unit because you need review video 2. You need review video 3. I want to get you the video on the quiz. So that's only 3 more. That's not bad. That's not the end of the world. Oh, yeah, and the reason I mentioned it is because I might do yet a 4th one and redo Euler 6 with functions. Because usually I do it at the end of this, but I want this to be a quick hit. I want you to, get out of Dodge. Plus, I got to get home and start working on my other project that I'm doing. So, but I do want you to see that because we solved Euler 6 in Unit 2, but now there's a more efficient way to do it because we have functions. And it's efficient. Maybe you know what? I'm going to wait. I'm going to wait until after review video 3 because not only will we break it down and do that problem with functions, I will save those 2 functions in a library. And you won't know about that until the end of Unit 3. So maybe we'll wait till then. That's what I'll do. Hopefully, maybe I have some time this weekend. Oh, this weekend's HackRU. If you don't know about HackRU, Google HackRU. Over at the Student Center on College Avenue, this Saturday and Sunday is going to be the hackathon event for the computer science kids in the computer science department. So everybody's going to be over there. I'm actually a judge on Sunday. So if you're not doing anything, stop by because it's really wonderful. There'll be like 600-700 kids there. just, going into groups and creating websites and creating programs and doing all kinds of interesting creative projects. HackerU is really cool. Actually, I got the HackerU t-shirt on today. So stop by if you can. But that's why I'm crazy busy this week. I'm trying to front load all my work, because usually it's like, I'll do that on the weekend. I'll do that on the weekend. This weekend I can't. I'm going to be in HackerU the whole time, and I know I'm going to be there. So I'm trying to get everything done. All right. So this is the end of this video. Remember, you've been using built-in functions all along, and I wanted to remind you of that and show you that right there. As far as the anatomy of a function is concerned, you have a name, you have arguments or parameter lists, and you have a return value, and this is how we create our own. We use the def keyword, then we use a name just with the same conventions as you'd create a variable. And then underneath it, after a colon, we create a code block, and it contains all of our logic and all of our code. When I run this, it's not run, it's put in memory, okay? Then I can call it and print it with all the different numbers, and I never have to write that code again because I've already done it. I've got my function, okay? Remember 2 things about functions. You have to be wary of scope. That function's going to go off, run, and then disappear. So don't try to access variables in it when that function's already run, because technically they don't exist. And the second thing you have to be wary of is make sure and capture a value if you've got a fruitful function going on, because otherwise nothing's going to happen. All right, you've either got to print it or you got to capture it with a value. Given the choice, capture it with a variable. I meant to say variable, not value. All right? All right, good. Then I'm saving this, and I'm going to put this up on Sakai. I am not going to kill you with announcements right now, because you're going to get video 2 in the next couple nights, and then video 3, and blah, blah, blah. Except to say 2 things. 1, think about groups. I've got 2 groups right now. At the end of the day, we're going to have 12 or 13, so get going on groups if you want to work with certain people. And number 2, I know it's the 10th. I know it's not due till November, but start thinking about that midterm project, okay? Because you need to spend 2 hours watching the Harvard video. You need 2 hours learn Python the hard way. 2 hours Code Academy. You want to keep notes, and you want to compare and contrast, and you want to think about these different educational methods, okay? All right. Then I'm going to get out of here. You enjoy. Any problems, put them in the forums or send me an email, all right? Me and the boys are hard at work creating the Unit 2 stuff. A lot of people did really well, so I really like what I'm seeing in this class. This is a good class. All right? All right, then I'm out of here. I'll talk to you later.